Hi everyone, welcome back. I'm Jason Baskin, and in this video I'm going to describe the process for creating a stretchy leg setup, sort of like the one I have for my Mike and Tina character. You can see that when the leg control is pulled up, that the knee bends normally, but when the control is pulled beyond the normal range of the character, that the leg will stretch to always reach that control. And these stretchy leg setups can be really handy for creating squash and stretch, but also for dealing with characters with really short legs where you need to keep the feet planted while the body is moving around. So we'll begin the setup by just building a basic IK leg. You can see this IK leg doesn't have any stretch activated, and it's just a basic leg setup with foot pivots. And if you don't know how to create this kind of leg setup, check out my other video. I go through the whole process of creating this sort of simple IK leg setup. The next step is for us to create some locators that are going to measure the distance of the leg from the hip to the ankle. And we're going to use that information to determine when the leg needs to stretch. So we'll go to the Create menu and choose Measure Tools and activate the Distance tool. Now I need that measurement to be exactly from the location of the hip joint to the ankle joint. So I'm going to hold down the V key to activate vertex snapping, and then I'll left mouse click once on the hip and then once again here on the ankle, and we'll see that the measurement is shown right here in the viewport. This distance is about 9.2 Maya units. So with these locators built, we want to connect them to the movement of the leg. And so I'm going to use some constraints to do that. I'm first going to start out with a point constraint because the location of the hip joint is at exactly the location as this first locator, which I'll name Start Locator. So I'll create a constraint by selecting the hip, shift selecting the Start Locator, and choosing Constrain Point. And now if I move that hip joint around, you can see that the locator follows along, and the measurement value also updates to indicate what that linear distance is between the first locator and the second locator. I'll select the second locator. I'm going to name this one End Locator. And this one actually cannot be constrained to the ankle joint. It would make sense that you'd do that, but when we create the whole stretchy setup, it's actually going to create a cycle error because we're going to be adjusting the length of the joints based on this measurement. Maya doesn't like to have those elements connected so closely, and it creates an error. So instead of having it follow the ankle joint, we'll have it follow the foot control. So I'm going to select the foot control, shift select the end locator, and in this case, I'm going to constrain it with a parent constraint because the pivot points are not in the same position, and I'm going to be rotating this point around, so it's going to need to receive that orientation information to keep the locator in the right position. So I'll go to Constrain Parent, and I'm going to go to the options, and I want to make sure that the Maintain Offset setting is turned on. And I'll click Apply. So now we can see that the end locator also follows the location of the foot as it's moved around, which is exactly what we want. All right, so there's various ways that we could activate stretch on a leg setup like this, and I'll try to go into detail on different ways that this can be done with utility nodes and that sort of thing in another video, but I think the simplest way to do it is actually to use the expression editor, which is right here under Window, Animation Editors, Expression Editor. The expression editor involves a little bit of coding, light scripting, sort of like Mel scripting, and I'll walk you through it, and hopefully it'll make sense. The basic idea is that we want to adjust the X scale value of these joints. That's what's going to determine the length of the joints based on the length of the measurement here. So the measurement information is associated with this distance dimension node, and one of the things that can be confusing is that if you click on that node, you're not going to see that 9.2 value anywhere here, and that's a little weird. The information is actually stored in the shape node for the distance dimension. So we're going to have to first go to Display and turn on Shapes if you're looking at the outliner here, and then find that shape node in order to actually directly access that information. And it's also a hidden attribute, so that doesn't help us too much either. But the attribute that we need is actually just called the distance attribute. So I'm going to rename this and just give it a simple name. I'll call this leg distance. And then when we are working in the expression editor here, when we want to access that value, that length value, we're just going to refer to the leg distance dot distance attribute. All right, so the process for us here in the expression editor is first that we want to adjust the scale value for the hips and the knee joint based on this value. So the syntax in the expression editor is always going to be the name of the object followed by the name of the attribute. So I've already done that here. Leg distance is the name of the object, distance is the name of the attribute. So for the hip joint, I'm going to type hip, that's the name of the object, and we're going to be adjusting the scale x value. Again, the scale x value is what determines the length of this joint. And we'll say that the hip scale x is going to be equal to, and I'll just use this value, the leg distance attribute, which is actually 9.2 units. So if I create this, you can see that the hip is going to grow huge. And the reason for that is that my original scale was a scale of 1, and now I've scaled it to 9. So I don't want to do that. What I want to do is take this distance value and normalize it. So I want to have the value be set to about 1 when the leg distance attribute value is at 9.2. So I'm just going to divide this leg distance attribute value by a value that's going to give me a good baseline for when the leg isn't stretching. So I'm just going to set it to 9.2, and I'll hit edit. And so now we can see that the hip is back to a value of a scale of near 1, and when I move this around, you can see that that hip is stretching. So it's starting to work, but the leg is still slipping off of the location of the foot control. And the reason for that is that I haven't set up an expression yet for the knee. So let's go back to our expression. I'll go to the select by filter, and I'm going to choose by expression name so that I can find the expression that I've just created. It's this one right here, and you can name these expressions. So I'm going to call this the leg stretch expression. You can see I have a couple other expressions for my other rig in this scene. But you can actually adjust multiple different objects with a single expression. You just need to remember that every line that you enter in the expression editor has to be followed by a semicolon. So I'm actually just going to copy this expression and paste it down below, and I'm going to do the same exact thing that I did for the hip with the knee. So I'm just going to adjust the knee scale x value, which determines the length of this joint, based on the leg distance, which I've normalized to be close to a value of 1 when the leg distance is 9.2. So I'll hit edit, and you can see now that the leg is stretching and it is consistently maintaining the appropriate distance so that the foot control never slides away from the leg. So this would be great if we never needed to have the leg bent, because it's just always reaching the foot control. But ordinarily, that's not what animators like to work with, because it's nice to be able to convey weight and have the knee bend, but to get that stretch in just when the controls are being pulled beyond their normal range. So what we want to do is set up a conditional expression so that this stretch value will only activate if the leg is pushed beyond a certain range. And so we're going to do that in the expression editor by typing in a conditional statement, and the conditional statement will be if something is happening, then we're going to do this stuff. And if that's not the case, we'll use else, and we're going to do some other stuff. So within the conditional statement, we use these curly brackets, and that means that these two statements are going to be activated if a certain condition is satisfied. And otherwise, we actually know already what we want to do to the hip scale if the condition isn't satisfied, which is that we want the hip and the knee scale to be set to a value of 1. So hip scale x equals 1, and knee scale x equals 1. This indentation isn't actually necessary for MEL scripting, but it's a really common coding practice, and it makes this script a lot more readable. All right, so what's going to go here in this if? Well, if the if statement, all we're trying to determine is the distance of our leg distance node greater than it needs to be? So if the leg distance dot distance is greater than a value of 9.2, then we're going to scale the legs. If it's not, so else, then we're going to set it to 1. And that's it. That's the whole process. So if we hit edit, you can see that now when I move the leg beyond its normal range, it's going to stretch. And if I compress it to the reach of its normal range, then the knee is going to bend. So again, what we did is created a couple locators to measure what that distance is, and then we created an expression to say that we're only going to activate the stretch if that distance goes beyond its normal range. And you could adjust these numbers a little bit if you wanted to. You could see I rounded it slightly. Sometimes you want to account for the fact that the knee has a slight bend. But this is the basic idea, and it's the same concept that's used for stretchy legs and arms and back and all that sort of thing. Now there's some other layers to this, being able to turn stretch on and off, again being able to use utility nodes, and I'll try to address those in another video. But hopefully this will get you started creating stretchy limbs for your characters. And if you found this video helpful, I'd invite you to subscribe to my channel and also to check out some of my rigging tutorials on lynda.com. All right, thanks for watching.